All right, so we'll pick it up where we left off last time, talking about variables in Java and variable types. We've got the familiar integer and double, and we do have characters. Characters are single characters, but in Java they're Unicode characters, just like they are in Python. Don't worry about that. That just means that you could use, CJK fonts, international fonts. You can use emojis and things like that, but we won't do that. But instead, you have strings. A full class of strings where you can actually use a double quotes, and not single quotes, but double quotes to encapsulate a sequence of characters. And you don't have, it's just like Python, you do not have any of the headaches that go along with strings like in C, where strings are full character arrays, and you have to be wary of memory management, and you have to be wary of the null terminating character and stuff like that. You just have strings, right? We left off talking about the limitations, or previewing the limitations of integers. So in Python, you can do something like this. You can just go ahead and mash the keyboard as much as you want and have an arbitrarily large integer. That's not going to work in Java, just like it doesn't work in C. Instead, an integer is limited to 32 bits. A bit is a 0 or a 1. And if you only have 32 bits to represent a number, the maximum number that you can represent is 1 to the 32 minus 1. Or 1 to the 31st minus 1, excuse me. Now, why 31? Well, because of your 32 bits, you need one of them for the sign bit. 0 for positive, 1 for negative. Consequently, that one goes away. Because it's base 2, zeros and ones, you can represent 2 to the 31st. Why minus 1 here? Well, you got to start somewhere. Where do you start? At 0. So the maximum possible value that you can express with a 32-bit signed 2's complement integer, don't worry about the details there, is about 2.147 billion, right? So I'll just go ahead and name this large, right? And that's the largest amount that you can actually represent. Let's go ahead and print that out and show that it actually works. System.out.println large, right? Now, what if I were to try to add 1 to this? So first of all, what are some operations that I can use to add 1 to large? Add 1 to large. Right? Large is equal to large plus 1, right? That will work. Remember, semicolons end all executable statements here. And remember that we are online, so if you have any questions, and if you're following online, you can go ahead and post to the YouTube live chat here. But anyway, plus 1. Now let's go ahead and print that out, and then we'll come back and look at other ways of doing that. What's going to happen here? 2.147 billion and change, ... should become 8. In Python, it would, because you can represent arbitrarily large numbers. In C, it doesn't. What does it end up being? Something, well, not invalid, but negative. Why? The numbers are a circle, right? 0 starts here, and you go 1, 2, 3, 4, 5. You go negative 1, 2, 3, 4, 5. And so if you go too far, you end up on the negative side. That's called overflow, right? So add 1 to large, causing overflow. And just in case you're wondering, yes, you can cause underflow. If I have negative 2.147 billion and change an 8, right? This is the smallest number that I can represent. Why 8 now? Well, because you already started out at 0 going to positive. You don't need to start at 0 going to negative. You start at negative 1. And so you can go all the way up to and including this number. This will work, right? Once I save it, right? Because I'm adding 1 to a negative number. But what if I subtract 1 from it? It's going to go the other direction, back to positive, right? The number is a circle. The number line is no longer a number line with infinite ways both ways. It is now a circle. Overflow goes to the other direction, right? Underflow goes the other direction. So let me go ahead and restore all of this stuff. And just understand that it's a limitation of 32-bit, of finite numbers, right? Just like, what if I were to represent 1 divided by 3, right? Well, if it's 3.0. Is that exactly going to be 1/3? Let's find out. Double foo is equal to 1 divided by 3. Right? Now, what if I add foo to itself 3 times? Double bar is equal to foo plus foo plus foo. What should it be? What should bar be here? Mathematically, it should be 1, right? 1/3 plus 1/3 plus 1/3 should be 1, mathematically. And it does end up being here in this case, but internally it's probably rounding off, right? It's probably actually doing something under the hood here to actually get 1. Internally, though, if you were to look at foo at this point, it is going to be, let me go ahead and print this out with many decimals of accuracy, percent, like 40 decimals of accuracy here, right? Foo. Is it going to be 33333 all the way off to infinity? No. You only have 16 decimals of accuracy with floating point numbers. That's the same in Python. That's the same in C, by the way, right? You do not have natively built-in arbitrary precision floating point numbers in Python, okay? If you do ever have an occasion to want to have arbitrarily large and arbitrarily precise numbers, you can use big integer, I don't know, x, or a, say, and big decimal x, right? And of course, you would have to bring these in, import them. Oops, nope, not creating the class, but big integer, you got to spell it correctly. All right, there we go. And now you can import it. Import this class, which is in, I think, the math library, and big decimal. And those are arbitrarily large, arbitrary precision that you can then set and tune. Every language supports this, either through a standard library or through an external library. C, GMP would be your library of choice. Python, I think, what is it called? Big decimal, is it in there too, or something like that? Decimal, I think it's just called decimal or something. But I'm just going to mention these because they do exist, if you ever need them, right? But otherwise, what's another way that we could have done an addition here? Right? Large is equal to large plus 1. What's another way? Or, how can I add 1 to a number? I can use a compound assignment operator. Large plus equals 1. Add 1 to whatever's on the left-hand side. Python supports this. C supports this. What's another way? If you just want to add 1 to it. Large, no? Plus plus, right? C supports that. Most programming languages support that. Python doesn't, right? Why? Don't ask me. It supports this. It supports the compound assignment operator, but does it support the increment operator? No. So that is something new that you can get used, that you should get used to if you're coming from a Python background. I'm going to go ahead and copy all of this into the notes, and let's review what we've looked at so far. Java. Right. Oops, and add to it. All right, so first of all, an integer type. An integer type is an integer, right, with 32 bits, bit representations, right, limited to integers in the range, What was our negative value there? Here, I'll just cut and paste this. Our positive value here was on one side, and the negative value here was on the other. So, and that was 8 to that one, right? So add your own commas if you want. That's not going to be valid in the actual code, but about 2.147 billion. If you have need of representing integers larger than that, then you need to bring in a library to do it, big integer. Double is a floating point number with about 16 to 17 digits of accuracy. Right? It doesn't matter how, I mean, it can get too big as well, but it can get much, much larger than 2.147 billion. It's just that the problem is you can only represent the 17 most significant digits. Exactly the same in both languages that folks here are familiar with, Python and C. Right? Why? Because technically under the hood, it's an IEEE 754 floating point number. Again, don't worry about that kind of detail unless you're doing systems level programming, eventually. Right? A character is a single Unicode character, right? But you generally ignore that because, of course, you can afford a full string type. String types of automatic concatenation, if you want to take two strings and add them together. For example, let's go with string A is equal to hello, right? And on string B is equal to world. Right? Note there I already put in the space. If you want to create another string that is both of those strings together, you don't have to set up memory. You don't have to call a function strcat to do it. You don't have to make sure that it's null terminated. You just do it. Right? C is equal to A plus B. In this context, that does not mean addition. That means concatenation because both sides are strings. If you have a string and a number, you can concatenate those together as a string. Only if you have a number and a number, an integer or a floating point number, it doesn't matter, does it mean addition. Right? System.out.println C. There we go. And this is going to be hello world. Now, one difference from C that that'll take some getting used to, but that it's the same in Python, is that strings are immutable. What do we mean by immutable? It means that they cannot be changed. Once a string is created and it contains the contents hello, right? That's it. You can't change that ever again. That's exactly the same in Python. You just may not have known it, right? In C, of course, they are string arrays or character arrays, and so you can change them all you want. You can't do that in Java, right? In Java, you can't say a sub 0 is equal to a lowercase h instead, right? Because it's not an array, right? You can't do that in Python either. We'll get to strings more, in more depth later on, where they've got this entire library associated with them. C dot, you can go ahead and dump it to a character array, right? An array of characters. You can concatenate one string to another string, but it only produces a brand new string. It never changes the other string because you can't change a string. They're immutable. They are unchangeable. The opposite would, of course, be mutable, where you can change it. You can mutate it. Right? But in Java, they're immutable, just like in Python. Okay? Yeah?
If a string is a variable, could you then change that variable and just have it recalculated later?
Yep. So temp, I'm going to go ahead and temporarily store a reference to hello, right? And then I'm going to change what A is referring to, creating a brand new string, goodbye. Right? There we go. Now, those are completely new, different strings. In fact, let me go ahead and prove that to you by running a debugger that we'll get into here in a moment. Right? So, how many strings do we actually have? We have A, which is hello. It's not changed, right? We have B, which is world, and then we didn't touch it after that. We have C, which is the concatenation of those two things. And then down here we have temp. After I go to the next line here, there we go. It's going to have the, or temp, come on. Temp should have hello. And then what's A now? It's highlighted here in yellow. It has been changed to goodbye. Now that means that a new string was created with goodbye and then the reference was switched over to it. It does not mean that the original string was changed because, of course, temp is really still pointing to hello here. Right? This is a debugger. We'll talk about this here in a moment. Okay?
Okay, cool.
Right.
That's all I was worried about, just being able to change the string variable.
Yeah, you can always change it. You can always change whatever variable you want. Now, you can't do something like this. Right?
Nope.
A is now 10. You can do that in Python because Python has dynamic typing, right? Just in case you think, oh, I'm losing something. No, you're not. You're gaining something. You are gaining type safety at compile time, right? Mistakes like, say, calling a function that expects a string as input, you can go ahead and call that function and pass it an integer, and then it's going to fail, right? It's going to fail at runtime. Here, the compiler is smart enough to check this out and say, wait a second, that's a string, that's an integer, not going to let you do that. I'm not even going to let you compile, right? Whether or not you're gaining or losing is an opinion, right? And of course, that's why we have so many different programming languages with so many different features just like that, dynamic versus static typing, right? I'm of the opinion that static typing, and I think I would like to cross my fingers and hope that it's true, that the majority of the community is also into static typing, right? All right. There are plenty of languages that have incorporated, that were dynamic and incorporated static typing later on, or at least static typing additions. There's never been a statically typed language that incorporated dynamic types later on. So that's why I think I'm among the majority. But count yourself wherever you want to count yourself. All right. All right, what else do we have here? Something that you experienced yesterday are command line arguments. When you run a Python script or when you run a C program, usually from the command line, you can do it interactively where it prompts you for input. Please enter Fahrenheit so that I can convert it to Celsius, right? And then what you do is you sit there and you mash your keyboard and give it some input, right? And you can do that, but the better way of doing things like that is through command line arguments, where you immediately run your program and then provide it all the inputs right there at the command line. So for example, if it were Python, it would look something like this. Python foo.py A, B, C, right? 1, 2, 3. There we go. Those are command line arguments when you execute a Python script. What would it look like in C? Well, a.out is usually what you compile it to, and then you provide it command line arguments here, like that. Where are the command line arguments when you don't have a command line? Right? They're up here in run configurations. You can go down to, instead of hitting the play button immediately and say printing out hello world here, system.out.println hello world. Right? There we go. Instead of just go ahead and just running this, you can go ahead and go to this drop down right here and go to run configurations. There's a lot of stuff that you can do, but what I want to focus on right now are the program arguments. Those command line arguments, the 1, 1, 2, 3, A, B, C, right? And then hello world, right? I'm putting those into double quotes there. It's kind of hard to see because I can't zoom in on that. But those are command line arguments. Apply that and run it. Now, of course, it's ignoring them. So let's not ignore them. First of all, how many command line arguments are there? This is a preview of arrays that we'll get to eventually, but args.length. Right? So, huge difference from C. In C, you have to do all the bookkeeping yourself. If you have an array, you need to also keep the size of that array in another variable and keep track of it. With Java, you don't have to do that. The .length property always keeps track of the size of the array. In this case, we passed in 7 command line arguments, right? ABC, 1, 2, 3, and then hello world. I encapsulated that in double quotes, so it treats it as one argument. Right? That's the number of command line arguments. And then, as a preview of conditionals here that we'll do next, you can check it. If n is not equal to 7, right, then we can do something about that. System.out.println expected 7 arguments. Right? Now, those of you coming from a C background, you'll immediately see that I'm off on my math. Right? In C, the first command line argument, and in Python, the first command line argument, argvis of 0, that's always going to be the executable file name or the Python script name. That is not the case in Java. In Java, what's the executable file name? In this case, it's demo. You don't need to be that doesn't need to be passed in as a command line argument. Right? So I'm actually passing in 7 arguments here. What are they? System, or then, well, by the way, we can do something about it. System.exit. We'll just go ahead and kill the entire program if we don't get the input that we're expecting and that we need. Right? And we can print them out. System.out.println args sub 0. Both languages are 0 index, so that won't be new to anybody, right? The first argument in an array or a list is always going to be at index 0. 1, 2, 3, 4, 5, 6, 7. I don't know how many I did there. 1, 2, 3, 4, 5, 6. Should I go to 7, by the way? No. If there are 7 command line arguments, it goes from 0 to 6. Let's just go ahead and print it out and see what happens. Right? Expected 7 arguments. Ooh, I didn't give it 7 arguments. Sorry. Didn't I? I thought I did. A, B, C. Oh. Sorry. Those are dots. I don't know why I was doing there. I was hitting the wrong button. There we go. There's 7 arguments. Right? 1, 2, 3, A, B, C, hello world. What happens when I try to access something that is outside the array? Well, in Python, you would get an exception just like this. In C, what happens? Undefined behavior. Anything can happen. You can go ahead, dead beef, it could be a segmentation fault, a bus error. It could be all right, right? It could just be memory that you're corrupting and it doesn't manifest itself until much later in the program, right? But in Java, just as in Python, if you try to access something that doesn't exist, you get an exception like this. And it's in red, so it's an error. The standard output is in black. The standard input is in green. We won't go over that. But the standard error, which you can also actually print to instead of the output, system.error, right? I am providing 7 command line arguments there, but that's how you can print to the standard error. You always have the standard input, your keyboard, and the keyboard mashing. You have the standard output, your console, in this case, the console, and you also have the standard error, right? That's the standard error output. And over here, it'll appear in red, okay? All right, so let's go ahead and get rid of that and review what we have here. The first one is going to be that 1, 2, 3, dot, dot, dot. Those are going to be helpful if they're actually numbers, right? The first 3 are numbers. So how do we convert those? So let's convert the first argument to an integer. So in Python, you would do something like int, right? You've got this function where you can convert a string over to an integer type. In C, what do you have? We don't remember our C at all. A to I, right? There we go. So I'm going to go ahead and convert it using neither one of those. Instead, it's going to be integer. Integer is a class, dot parse int, right? Args sub 0. That will end up parsing that as an integer. If it's not an integer, it will throw an exception and red madness and probably kill the program. We'll see that here in a second. How do I convert a double? Y is equal to, well, following that same pattern, how would you convert a double? Double dot parse double, args sub 1, right? How would you do this in Python? Float, right? All right, so let's go ahead and do that, and let me change it to show and print these out. System.out.println x and y, just to show you that we are successfully converting these values here. Run configurations. I'll make sure that instead of that 2, it'll be 2.56 or something, right? Save that. Apply, run, and there you go. There they are as integers and double types. There they are as string types, okay? Wow. Cut, paste, cut, paste, cut, paste. Should I have done that? Yep. As a preview of what we're going to do here shortly, you should probably be doing this in a for loop, right? Now, we'll get into it a little bit more depth for Python folks that are only used to for x in range, right? Range of 0 to, say, 7, right? That'll actually go from 0 up to 6. We're going to show you how to do that in Java instead. C folks, feel free to tune out because it's exactly the same. For int I equals 0, I is less than args.length, I plus plus, right? Ith value. Come on. Whoa. Okay, there we go. All right. It just froze up entirely. The entire thing froze up for a second. Okay. Let me go ahead and run that. Now we're good on OBS. Right, there we go. Same exact results as before, but now we're doing it in a for loop instead. So to understand this, this is an initialization condition. Right? We start I at 0. While I is less than, strictly less than, args.length, we will continue this loop, I plus plus. Each time we will increment it by 1. So it goes from 0 to 1 to 2 to 3 to 4. It's the exact same behavior as your traditional for loop using the range function in Python as this. It's just a little bit different syntax. Again, this is a preview. We'll get to it in a moment. Otherwise, preview of conditionals, preview of loops. Right? Questions on command line arguments? No? All right, let's go ahead and put this over in the notes so that you have it. Oops, there we go. All right. So let's talk about conditionals in depth here. All right? You have traditional if, else if, and else if. Those coming from a Python background, however, will recognize the structure, but it is different syntax. We have else if with a space in between it. We don't have elif, E-L-I-F, right? Otherwise, those coming from a C background, again, feel free to go ahead and tune out until I tell you to tune back in on this because it's exactly the same, right? So let's see. Hawks score They scored, I think, 4 last night. And then they were playing Calgary Flames. Score, they only scored 1. Right? Who won? By the way, these are both integers. Right? So who won? If the Hawks score was greater than the Flames score, then the Hawks won. System.out.println, Blackhawks win. Right? If you don't know what I'm talking about, that's fine. Who cares? It's hockey. Right? Else if, well, what's the other possibility? What's another possibility here? If the Flames actually scored more, right, than the Hawks, then who won? Or what happened to the Blackhawks if that had happened? Right? They would have lost. Is there another possibility? Yeah, they could tie, right? Else, system.out.println, tie, overtime. There we go. Oops, not Flames, but Flames score. There we go. Okay. So, because the Hawks scored more, it's going to print out what? That the Blackhawks win. Right? Now, if the situations were reversed and the Flames scored more, then the Blackhawks lose. Right? If they both scored only 1, then we would have gone to overtime. The if condition is standalone. You can write one if condition. Execute this or don't execute this. Exactly the same in both languages, Python and C. Right? The else statement is always going to be optional. Right? You don't have to put that in there if you don't want to. If you put an else if, then you need at least one more condition. You can have as many else if statements, else if statements, else if statements that you want. Right? Both languages are exactly the same. Right? The only difference here is syntax. Instead of having the colon and indentation, you have an opening curly bracket and a closing curly bracket. Style-wise, you should locate that else if statement on the same line as the closing curly bracket, the opening curly bracket on the same line as well. Right? You should always have these curly brackets there. If you don't have the curly brackets, then it only binds to one statement, and I'm not even going to get into that mess. Always just put in curly brackets there. Okay? Another difference is, in Python, you would have the keyword elif. You do not have that in Java. Right? Instead, you have to write it out, else if, with a space in between. Why? Because, dirty little secret here, there is no else if statement. It's just else, and then another if statement, right? And that's it. But syntactically, like stylistically wise here, this is how we write it. And it appears that it is actually an else if it's actually a reserved word or reserved combination of words. Okay. So you have if else if statements. I'll put that into the under the conditions. Oops, Java. There we go. Now, in both languages, you could do something like this. Is student. Right? Now, both languages, in C, you don't have Boolean types unless you bring in a library. In Python, you have built-in Boolean types, or you can use numbers, right? 0 is going to end up being false. Anything that's not 0 is going to end up being 1. I don't know if you did that as a matter of course in Python or not, but you shouldn't, right? And you can't in Java. Instead, Java has built-in Boolean types, right? Boolean is student, right? And you can set it to either true or you can set it equal to false. Both of those are both lowercase, all lowercase. In Python, of course, you had to have true, there we go, if you spell it correctly, and false. Neither one of those works in Java. Instead, it is case sensitive and it's all lowercase, right? Then you can use that Boolean. Let me go ahead and reformat everything. Then you can use that Boolean in a statement. If is student, right? By the way, I'll come back to it in a second here, but system.out.println, you get you get free tickets, right? I don't know which sporting events students get free tickets at, but I don't know, any? Up in Omaha, they get free Mav tickets to hockey, right? You pay full price. Maybe you get discounted stuff to, I don't know, basketball or something like that, right? There. This is a Boolean type, right? You cannot do something like this. Int is student equals true. 1 is true. 0 is false, right? That is syntactically not correct in Java. You should avoid that in Python anyway, and you should try to avoid that in C, but understand that that's the way that C does it. You should bring in the standard Boolean library. You can't do it in Java at all, right? You can't, it won't even compile, right? So if you want a Boolean variable, great. If you want to use a Boolean variable and then you do stupid stuff like this, if this is true, don't do that, right? That is cruft. You don't make an equality statement when it's a Boolean statement already. If they are a student, they get their discount, right? You don't add that additional complexity there, okay? All right, so you have built-in Boolean types as well. All right, so some notes here. In Java, you have full Boolean variable types, right, that you should use, you need to use, right? You cannot use numerical types as substitutes, right? You have the keywords true and false, right? These are case sensitive, right? You also have numerical comparison operators. For example, if I write just strictly less than, that's strictly less than. You have less than or equal to. You have greater than or equal to. You have equals, equals. You have not equals, right? Those are the same in both languages, okay? However, numerical types can only be used for numbers, not strings, not objects, etc. You can't even use it for arrays. I mean, that's something you can do in Python, but then what does it mean? This array is less than this array? It doesn't make any sense. This array is equal to this array, or this array is not equal to this array. That would make sense, but that's not really what you want to use, right? So what do I mean by that? Let's come up over here, and let's say that we've got int, or let's go doubles. A is equal to 10, B is equal to 20, C is equal to 30, right? And I'm going to check to see if I could use these coefficients in a quadratic equation, right? So what I've got here is a double radical is equal to B squared plus 4AC. Now, first of all, is that going to work in either language, Python or Java or C? None of those, right? What about this right here? So I'm trying to raise B to the second power. Is that going to work in Python? Is that how you raise powers in Python? No. In Python, you have star star. In Java, you don't have that. In C, you don't have that. If you want to raise a power, what do? You use the math library, which we'll talk about here in a second. Instead, you just go B times B, right? If you want B squared, it's just B squared. Otherwise, if you do want to raise to an arbitrary power, you have this math library, math.pow, right? B raised to the power 2. In fact, you have a lot of math functions, right? You have math.square root. That should look familiar. You have math.sine, right? Tangent, cosine, et cetera, et cetera, et cetera. In Python, you would have to import the math library to do this, right? And then go math dot. You don't have to import it here like we had to import big decimal or other stuff like that, because it's part of the Java language itself, right? C, you would have to bring in the math library, include the math library. You don't have to do that here, right? And the other change is that you have to refer to the class, which is an uppercase M, because all classes should start with an upper camel casing, right? There's my power. Of course, it would be better if instead I did B times B. That's more efficient, but I'll leave this here as an example. Now, can I write multiplication like this in any language? There's no language that I know of that allows you to do this. Instead, what would you do? 4AC is an explicit multiplication. So now let me check that radical. If that radical is less than 0, right, then system.out.println, complex number. Hopefully we all remember the quadratic formula, right? Negative b plus minus square root of b squared minus 4ac. So if you've got that b squared minus 4ac and it's negative, you're going to take the square root of a negative. I wonder what happens. Right? Let's go ahead and ignore that warning right there, and let's go ahead and try to do something like this. So result is equal to math.square root of that radical. Now, first of all, is that going to work? 400 minus, oh, well, I don't know. Let's just go ahead and pump it up so that it's, pump it down so that it is definitely negative, right? Oops, double. And then let's print it out and see what happens. System.out.println result. So the question here is, does Java support complex numbers natively or not? And the answer is, oops, I want it minus 4 AC. Oh, thank you. I don't know the quadratic formula, apparently. All right, there we go. Well, that's me printing out complex number right there. And then what is the result? Not a number, right? I believe in Python you do have native support, built-in support for complex numbers. Don't quote me on that. It'll end up being I something, right? In C you don't either. You have to bring in a library to do it, right? So what happens? Not an exception. It's not fatal, right? It's just not a number. Not a number plus 1 is still not a number. Not a number times 1 is still not a number. Right? So math results like that can occur. What happens if we try to do something like this? A math.log of 0. Is that defined? What is the logarithm of 0? It's not a number, right? It's what? Negative infinity, right? All right, so be careful of various pitfalls that you could encounter by doing various math things. Right? All right. Can you do something like this with strings? Let's find out. String A is equal to apple. String B is equal to banana. Now, if you were in Python, you would want to know, do apples come before bananas? Do they? Printf, or system.out.println. A comes before B. Right. So can I even write that? In C, what would happen? It would compile, it would run, it would give you really weird results. Why? Because it would treat them as memory addresses, that you're comparing this memory address to that memory address. In Python, you can do this, I believe, right? Yes? No? I'm 99% sure that you can do something like this. And apple will come before banana. You can't do that here. Why? Because these are not numbers. You can only use these things with respect to numbers. Else if B is, A is greater than B, then I'll print out that B comes before A. Else, what's the only other possibility here? That they are equal. Equals B. Right? So how do we go about doing this properly? Right? What we need to do is we need to use a function. Those coming from a C background, what function would you use to compare strings? strcmp, a comparator function that follows the following pattern. If A comes before B, then it returns something negative. If B comes before A, then it returns something positive. If they're equal, it returns 0. Oops, let's go ahead and go with int result is equal to, I'm going to compare A, compare to B. Now this is going to return something positive, 0, or negative, depending on the relative ordering of those things. You tell me, does apple come before banana or not? If the result is negative, then that means apple comes first. Otherwise, if the result is positive, then that means that banana comes first. Otherwise, they're equal. Clearly, they're not equal, right? Which one of these things should come first? Just pull out your dictionary and you tell me. Right? Apple comes first. Apple comes before banana, right? And if I switch these around, or did something else, orange, there we go. Which one of those comes first? Banana comes before orange, right? If they're equal, and I've got 2 bananas, right? Banana is equal to banana, right? Even though they are different strings. In this case, actually, the compiler will recognize I'm creating two strings of exactly the same thing, and it'll collapse them down into one thing, right? All right, apple and banana, but with a capital B. Now you tell me which one of these things comes first. It ain't the dictionary anymore. What is it? It's the ASCII text table. This is true in both languages. Which one of these will now come first? Banana comes before apple. Why? It's a capital B. Capitals come A through Z before lowercase a through Z. If you want to compare them without regard to case, what you need is something else. In C, that would be str case CMP. In Python, I think it's case. You want it case insensitive. Ignores case. I don't even know how to do that in Python. And it's probably some function that you would use. Not ignores case, but ignore case. There we go. All right, so now apple will come before banana, even though it's capital B. Why? Because it's ignoring the uppercase, lowercase differences. All right? There we go. What about 1, 2, 3, and 9? These are numbers, right? They're not numbers. They're strings. So if they were numbers, which one would come first? Because the natural order is to sort in ascending order, so 9 would come first, then 123. What about if they are strings? Which one of these comes first now? Just the opposite. 1, 2, 3 comes before 9. Why? Because they're strings. 1 and 9. The ASCII text table, it's ordered 0 through 9, and all the numbers come before all the letters, right? So if you type, weird punctuation stuff, right? There we go, right? And other weird punctuation stuff, right? Who knows which one of these comes first, right? Okay, great, that one comes first. Why? You look at the ASCII text table and you see, well, somebody just put that first, okay? There is some rhyme and reason to that, though. So apple and banana. There we go. That's the proper way of comparing strings in C. So string comparisons, you cannot use the less than, greater than, etc. Right? Instead, you need to use this demonstration that I just gave you. There we go. All right. So you've got that in the notes. In our last 8 minutes here, what else can we do? Command line arguments. Sorry, we forgot one very important thing, right? You can create more complex logical expressions using connectives. Right? For example, the logical OR. In Python, what would it be? The word OR. In C, what would it be? Do you remember what these are called? Sheffer strokes or pipe or something like that. You do not have the keyword OR in Java. Instead, this is what you need to use. What about the logical AND? What would that be? It would also be AND, A-N-D, all lowercase in Python, but over here in Java, it's going to be just what it was in C, ampersand, ampersand, right? Two of them, it's important. Both of them require 2 characters, right? The single characters are bitwise operators. It's called bit twiddling, and it's not something we get into in depth. But both languages support it. When I say both languages, I'm always referring to Python and Java, knowing that most of us are coming from one of those 2 backgrounds. Okay? You have the logical negation, right? Not. Right? That's the same in both languages. However, in Python, you can use either this or you can use the keyword not. Right? But in Java, you can only use this. Okay? So, for example, you can check if int a, b, c, let's set them equal to something 10, b is equal to 20, c is equal to 30. Right? If a is greater than b and c is equal to 30, then do something, something, right? You can have if a is less than b, or if c is not equal to 30, then you do something else, right? So you can go ahead and use all those connectives. Same PEMDAS rules as all languages. Parentheses, exponents, multiplication, DAS, whatever they all stand for. Right? I don't want to sound it out. But same PEMDAS rules in all languages. If you want to make sure that, that it's absolutely clear, then you need to make sure that you put these into parentheses, or b is equal to 20. Right? That makes sure that that and is, that would be the case anyway, because and has a higher order of precedence than or, but it makes sure that, that it's explicit. You're not paying by the character. Go ahead and put as many parentheses in as are necessary in order to make your code readable. Okay? But otherwise, you have those logical connectives. Right? And you can negate entire expressions as well. Right? All right. Any questions so far? No? Then loops. As we've already seen, Java has both for loops and while loops. And you've already seen one example of a for loop. We'll take a look at another example of a for loop on Monday. And then, of course, the while loops. And then we'll get into enhanced for loops and collections and arrays and stuff. Okay? All right, have a good weekend.